Our advanced question says, if there is no seasonal effect on human births, we would expect equal numbers of children to be born in each season. A student takes a census of her statistics class and finds that of the 120 students in the class, 25 are born in winter, 35 in spring, 32 in summer, and 28 in fall. She wonders if the excess in the spring is an indication that births are not uniform throughout the year. A asks, what are the null and alternative hypotheses associated with this question? The null hypothesis is there is no association between the season and the amount of children born. The alternative hypothesis is there is an association between the season and the amount of children born. Now B wants us to compute the chi-squared statistic. So to do this, using a calculator, you would plug in the data given to you in list 1, and in list 2, you would plug in the expected. So for our expected, we have 30 for each, because if you divide the 120 students equally between the 4 seasons, you would get 30. So once you calculate that using the chi-squared GOF test in your calculator, you get chi-squared equals 1.9333 and a p-value of 0.5864. So I realize I've been saying chi when really it's chi, but no biggie. So for C, it asks, how many degrees of freedom does the chi-squared have? So it has 3 degrees of freedom. Since there are 4 seasons, you would do rho minus 1, and that would equal 4 minus 1 since there are 4 seasons in a row. C asks, what do you conclude about the null hypothesis at alpha equals 0.05? And I said, we fail to reject the hoe that there is no association between the season and the amount of children born, based on a p-value of 0.5864, which is larger than our alpha of 0.05. This is the end of our advanced question.